Problem 9. The trace of a square matrix is defined to be the sum of its diagonal entries. Right? So for example, what is the trace of X? Okay, X is a 2 by 2 matrix. Then the trace is just the sum of its diagonal entries, which is 3 plus 2. Right? It is 5. That's the trace. And Y, the trace Y is a 3 by 3 matrix. Okay, Y is a 3 by 3 matrix. The trace of Y is 1 plus 0 plus 4. Okay, it is 5. Then what is the trace of Z? Z is a 4 by 4 matrix. Okay, and the trace of Z is 6 plus 1 plus negative 7 plus 0. It is 0. Okay, it is 0. So that's a trace. Right, easy to understand. Then for A, express trace A in terms of Aij. Right, so let's say A is a general matrix. And by matrix, the first entry, first row, first column is A11, A12 all the way to A1n. Here, A21 all the way to A2n. Sorry, AN1. Okay, here it's A22 all the way to A2n. Here's A12, A22 all the way to AN2. Right, so here it's ANN. Right, then what's the trace of A? Right, what's the trace of A? Trace of A is A11 plus A22, right, plus all the way to ANN. Okay, or it is the sum of AII, and I is from 1 to n. Okay, I is from 1 to n. Part C. Prove that if AB there are n by n traces, then trace A plus B is equal to trace A plus trace B. So what is trace A plus B? So let's say it's the trace of A plus B, right? A is A11, A22, right? A12. B is, B11, B12, etc., etc. So it's just the trace of A plus B. Right? This is a matrix A plus B. Okay, this is a trace of A plus B. So it is A11 plus B11 plus A22 plus B22, It's A1 plus B11, plus A22 plus B22, okay, plus all the way to ANN plus BNN. Right. Then, what is trace A? Okay, trace A is a trace of, write down this matrix, A11 all the way to A1N, A11 all the way to AN1, ANN. Okay, plus trace B. Trace B is just a trace of, B11 all the way to B1 and BN1, BNN. Okay, so trace A is just A11 plus A22 plus all the way to ANN. Here, trace B is B11 plus B22 plus all the way to BNN. Okay, so you can see these two are the same thing, right? These two exactly same thing, just right. The sum, the orders are different, right? But the sum are the same. Okay. Then part D. Part D. What can you say about trace alpha A? Right. So just trace alpha A. Right. It's just a trace of, you know, the function alpha A is just alpha A11 all the way to alpha A1n. Alpha A11 all the way to alpha AN1. Here's alpha ANN. Okay. So it is a trace. Then it is alpha A11 plus alpha A22 all the way to alpha ANN. Okay, we can extract, we can put alpha outside, it's A11 plus A22 plus all the way to ANN times alpha. And this is exactly the trace of A, right? So it's alpha trace of A. Okay, and is trace AB, for example, just now we've seen, right? Okay, let's say trace AB, right? Let's say AB, they are the same matrix. A is 1, 1, negative 1, negative 1. B is also 1, 1, negative 1, negative 1, right? You already know A times B is 0, 0. So you can see trace AB is 0 plus 0, right? Trace A is right, this is not a proper example, sorry. Okay, a very easy example, like I, right? Like an identity matrix, right, times whatever matrix, right? Let's say 1, 2, 3, 4 is the matrix itself. Right, so here, this trace, right, this identity matrix, the trace is 2. Okay, this matrix A, the trace is 5. Right, but here, the trace I times A, the trace is still 5. Right, so it's not trace A times trace B is equal to trace A times B. Okay, that's not the case.